During this lesson, we're going to continue looking at radical equations. Remember, when you're solving radical equations, the first thing you need to look at are the restrictions under the radical. Then you solve the equation by isolating the radical, and then last you check your answers for extraneous roots. So we're going to start off by checking our restrictions. There are two radicals here, so the restrictions have to work for both. So when I look at the 3x, the radicand under the first radical, I notice that 3 is positive, therefore x must also be greater than or equal to 0 to make a positive product. And then I look at the 5x plus 4, I get x has to be greater than or equal to negative 4 over 5. So for both of those to be positive, we can see that it is the overlap, the green. So this overlap right here is where both of them are positive. So x greater than or equal to negative 4 over 5, or sorry, I should be saying 0, is the restriction on the variable for this equation. So that is the overriding restriction. So now when we go to solve it, we have two radicals. They are isolated, but if I was to square the left side and square the right side, I would have radicals on both sides still because of the foiling, the expanding, the squaring of the binomials. So if I can, I would like to only have one radical in the next step. So I'm going to subtract 5 from both sides and get 2 plus root 3 equals root 5x plus 4. And at this point, I am now going to square both sides. On the right side of the equation, you can see the squaring and square rooting cancel each other out nicely, but on the left side it doesn't. So I go ahead and I square my binomial. 2 squared is 4. 2 times 3x doubled is 4 root 3x, and root 3x squared is 3x. So now I still have a radical, but that's okay, I just isolate it again. So I get the 4 root 3x on the left side, and I subtract the 4 and I subtract the 3x from both sides, and I end up getting 4 root 3x equals 2x. I also now notice that there's a GCF, so I reduce down and I get 2 root 3x equals x, and at this point I can now square again. So I square the left side, I square the right side, and I get 4 times 3x equals x squared. 12x equals x squared. It's a quadratic, so I set equal to 0. And it's a binomial, so it's either difference of squares or GCF. I see a GCF of x. And now, if this is 0, x is 0, then that solves my equation. Or if x is 12, I solve my equation. Now don't forget to check for extraneous roots. Let's go ahead and check 0. When I check 0, back into the original equation, I get 7 plus 0, which is just 7, equals root 4 plus 5. So that gives me 7 equals 7. That works. Let's check 12. When I plug 12 back into my original equation, I get 7 plus root 36 equals root 64 plus 5. I end up getting 13 equals 13. They both work. Therefore, they are both solutions to this radical equation. So in summary, you isolate the radicals the best you can. Try to reduce binomials so when you're squaring, you don't have to worry about you can only have one side having a radical. Then you isolate it again, square again. So let's try one more. Let's go down to this one here. Again, we need to look at our restrictions. So we look at our restrictions. There's two radicals. So in the first radical, x has to be greater than or equal to negative 2. Or x minus 2 has to be greater than or equal to 0. Therefore, x has to be greater than or equal to 2. And 3x minus 3 has to be greater than or equal to 0, so x has to be greater than or equal to 1. The overlap happens right there, therefore that x is greater than or equal to 2 is your restriction on your variable. So now when I go to solve this again, we have to isolate the radical as best we can. So I have 2 on one side, so that would be messy. So let's go ahead and move the root, the second root, to the other side. That changes it to subtraction. Now we're going to square both sides. When we square the left side, we get x minus 2. When we square the right side, we're going to get 9 minus 6. And if you want to write it out on a piece of paper and expand it that way, you can. But for speed, I'm going to do it this way. A negative times negative is a positive. 3x, minus 3. There we go. So again, I only have one radical, so I'm going to clean this all up and I'm going to isolate it. I'm going to move the radical to the left side so it's positive. I'm going to move everything else to the right side, so that gives me the 2x and that gives me plus 8. I'm also going to notice there's a GCF, each coefficient, 6, 2, and 8 can be reduced down, so I'm going to reduce that down to lowest terms while I'm here. And now I'm going to square again. So when I square the left side, 3 squared is 9. The root squared is just the radicand. When I square the right side, I'm left with x squared plus 8x plus 16. This is 27x minus 27 equals x squared plus 8x plus 16. Again, quadratic, so let's move everything to one side. So I subtract 27x from both sides, I add 27 to both sides, and this quadratic does not look factorable, so I'm thinking my roots are not rational. So when we can't factor, we go to our quadratic equation. Remember, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Plugging all of that in, you will end up getting that, the two roots, 9 plus root 189 and 19 minus root 189. I believe 9 goes into that 21 times, so we could even simplify it to 3 root 21 all over 2. And so those are our two roots. But again, we have to check for extraneous roots. Now checking for, I went way too far. Checking for extraneous roots with an answer with radicals, an exact answer, is kind of messy when you go back to the original question. So to check, I change them into decimals. First, I type in 19 plus 3 root 21 divided by 2, and I get 16.4. Again, knowing how to type that in to get to the correct answer is where a lot of mistakes are made. I go ahead and I check that back into my original, and I find out that that is extraneous. It does not work. Now I go ahead and I try my x minus 3 root 21 all over 2, and I calculate that to be 2.6. I plug that in and it does work. Therefore, my solution, I use the decimals to check, but my exact answer solution is that one. So I leave out the plus because that is the extraneous root. All right, so when solving, you have to isolate twice sometimes. Moving on. Extraneous roots are likely to occur when a negative is being squared, or also if variables are squared on both sides of the equation. So let's look at some examples and try to figure out which of the following may have an extraneous root. So in the first one, when I look at that, if I square the left and I square the right, I'm not squaring a negative. Therefore, the square root of a number could be positive. There will be no extraneous root. That is not going to happen. In B, the square root of a number is always positive. So the square root of x plus 6 equaling negative 12 is impossible. So you can see I'm squaring a negative, and that is creating an extraneous root. So B will absolutely have an extraneous root. C, however, it equals x. The root equals x. Therefore, when I square both sides, I could, if x was negative, be squaring a negative. I could be squaring a positive. So it is likely to have an extraneous root. It may. It's not for sure, but it may if x is negative. So you can see by my solutions that's exactly what happens. In A, no, it is not. It's not extraneous. B, yes, it is. And C, one of them works when x is positive and the negative is extraneous. So thinking that through and having a basic idea helps you for checking roots. The assignment is here. You're going to work on this assignment today. The quiz that you're going to have during your review class next day will be on dividing. radicals, rationalizing denominators, both monomial denominators, binomial denominators, checking restrictions. Don't forget, when you have a fraction, the denominator can't equal 0, and when you're simplifying, the conjugate cannot be 0 either, and on your basic radical equations for next class review quiz. One other little point I would like to point out, when we're looking at restrictions, sometimes under the radical you could have a quadratic, and therefore the quadratic radicand must be positive. So if you look at my restriction here, x squared plus 4x has to be greater than or equal to 0. When I factor that, I get x times x plus 4 has to be greater than or equal to 0. Now, to make that true, we have two cases possible. Case 1, if both are positive, you get a positive number greater than 0. If both are negative, you get a positive number. So it's an or situation, not an and. One or the other could happen. So we need to take each case separately. If they're both positive, then x has to be greater than or equal to 0, and the second factor, x plus 4, has to be greater than or equal to 0. And so both of those have to be true. That is an and situation. So that's when I look for the overlap. So greater than 0, greater than or equal to negative 4 results in just looking at this part. X has to be greater than or equal to 0. That is one case that creates a positive under the radical. Or if both are negative, x is less than or equal to 0, and x is less than or equal to negative 4. So this again, we need to look at the overlap because of the word and. Both have to be true. And means they both have to be true. So I look at the overlap, and that's when x is less than or equal to negative 4. So my final solution on a number line would look like that. That's all of those possible x values are allowed. Anything between negative 4 and 0 would not work under this radical because you get a negative radicand. One other little point, if you had something like this, x squared minus 4 under the radicand, x squared minus 4 greater than or equal to 0, I could factor it and do exactly what I did above. Or you could just solve it by isolating the x squared. X squared has to be greater than or equal to 4. Well, if you think about it, when you square root both sides, you get 2 or negative 2 in an equation, right? If you had x squared equals 4, x equals plus or minus 2. When you get the positive 2, you just write it like that. Well, 2 squared is 4, 3 squared is 9, 4 squared is 16. They're all greater than 4, so that works. But what happens with the negative root answer? X squared is not greater than negative 2. It's actually less than negative 2. So the sign reverses for the negative root. And that should also make sense because negative 3 squared is 9. Negative 4 squared is 16. So as you get to the extremes, the opposite is true when you get into the negative side. So that's why that reverses. So that's a little extra to do with quadratics underneath the root sign. All right, I'll put your assignment back up. You should have it written on your notes, and you can work on that.